That's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old.
Remember what Michio Kaku told us last year about the early galaxies captured by the Webb images? Well, brace yourselves because the James Webb Space Telescope is challenging everything we thought we knew about the universe's origins. Imagine 6 galaxies just 500 million years after the Big Bang, up to 10 times larger than our Milky Way. This defies the expected norms, shaking the foundations of our understanding. The textbooks might need a rewrite, and we're on the brink of a cosmological transformation. Get ready for revelations as NASA's cutting-edge telescope unveils the mysterious beginnings of the universe, taking us where no one has gone before. Exciting times indeed. This is Reveal the Mystery. If you are curious to learn mysteries of the world, space, and beyond, consider subscribing. Originally, the concept of the Big Bang wasn't a head-scratcher. It came from 3 solid facts neatly bundled in Einstein's general theory of relativity. Imagine a universe rocking an even spread of matter and energy. It can't just stay put, it's got to either squeeze in or stretch out. Think of it like the cosmic fashion runway. Now let's stargaze for a sec. Up in the sky, beyond our cozy Milky Way, there are spirals and elliptical doing a cosmic dance-off. We've got the cosmic measuring tape out, and guess what? The light from these celestial dancers is like a cosmic color-changing show, with the distant ones rocking a snazzy red shift. It's like the universe's own disco ball. Mix these cosmic clues, and voila, we connect the dots. Our universe, now all chill and expansive, must have had its wild days when it was a tiny, bustling hotspot. Enter George L.T., the cosmic maestro who dropped the knowledge bomb in 27. But hold up, it's not a solo act. Howard Robertson, Edwin Hubble, and Arthur Walker joined the cosmic bandwagon, each nodding to the universe's groovy expansion beats. Now, fast forward through cosmic history. We unveil more cosmic secrets. Early days, hotter than a summer BBQ, and denser than a cosmic pudding. As the universe spreads its wings, it cools off, leaving behind a cosmic chill vibe, like a universe-wide slushy of low-energy radiation in all directions. But here's the cosmic mic drop moment. Stars, galaxies, and a sprawling cosmic web, each piece of the Big Bang story, have been fact-checked and validated. Bye-bye, alternatives that can't keep up with this cosmic saga. Hold on to your cosmic hats because the cosmic revelations don't stop there. 3 more cosmic ingredients join the party. Dark matter, the cosmic wallflower, dark energy, like the Red Bull of space, and cosmic inflation, putting a speed limit on our cosmic time travel. This image opens up a world of possibilities. Thanks to inflation, we can delve into the initial conditions of the universe right at the fiery birth of the hot Big Bang. We're talking about the nitty-gritty details, how scorching and packed it was, the initial density imperfections, all the way down to those adiabatic Gaussian random fluctuations. And let's not forget the magnitude of these fluctuations across every cosmic scale. Our knowledge, fueled by the standard model and the extra spice of dark matter and dark energy, gives us the power to narrate the saga of various energy types and abundances across all cosmic eras. From that kickoff point, armed with our understanding of the laws and interactions governing the cosmos, we can time travel these initial conditions from the hot Big Bang kickoff to the present day. Theoretical predictions and numerical simulations become our crystal ball, foretelling what should unfold in an expanding universe that kicks off with a hot Big Bang, complete with all the properties we've pinpointed. But hold up, despite a boatload of observational evidence backing this cosmic portrait, we can't be too comfy. Every time we peek at the universe in a new way, it's like a reality check. We gotta ensure what we're seeing still vibes with this model. Enter the James Webb Space Telescope, NASA's cosmic superhero. According to Matt Greenhouse, who's been in the James Webb senior staff, this space marvel has cranked up the doubts about the Big Bang theory. As James Webb spills its cosmic tea, it's gone where no NASA instrument has gone before, giving us a high-def peek into the infrared universe. Buckle up for the cosmic drama. Before James Webb, we had one confirmed ancient galaxy, GNZ 11, chilling 400 million years post-Big Bang. Now, we've got over 100 galaxy hopefuls from James Webb, rewinding us back to the first 400 million years of the universe. Some of them are legit early birds, making GNZ 11 look like a cosmic neighbor. As the James Webb saga unfolds, it's rewriting the cosmic record books, promising dozens of new ultra-early galaxies. But here's the cosmic twist. These newfound early galaxies aren't playing by the rules. They're throwing curveballs, massive, bright, rich in heavy elements, stars and gas, things that don't quite align with the universe's theoretical script. It's like the cosmos is keeping us on our toes, challenging our cosmic narrative. The abundance of galaxies displaying these unique characteristics at such an early stage raises perplexing questions. Our understanding of how gas falls onto these early galactic bodies and how star formation acts as a feedback mechanism, preventing future gas accretion, suggests there should be a limit to the rate at which material can accumulate on these objects. While certain conditions might temporarily surpass this limit, sustaining such a process over extended time frames seems unlikely. Thus, when examining these early galaxies, an unsettling feeling emerges, hinting that something is amiss. It's evident that the galaxies captured by the James Webb Telescope possess a mass that challenges the feasibility under current cosmological theories. This revelation surprises Big Bang astronomers since, according to the prevailing theory, these galaxies shouldn't exist. The anticipation was for primordial dust, assumed to be the origin of stars and galaxies following a primordial explosion. The James Webb Telescope disrupts the status quo, questioning the widely accepted Big Bang theory and causing consternation in the scientific community, particularly among those adhering to the theory's origin narrative. Big Bang scientists assert that the universe's galaxy expansion stems from a singular explosion billions of years ago. However, not all scientists, including some evolutionary scientists, interpret red shifts in the universe as conclusive evidence of galaxies expanding or originating from a primeval Big Bang. Critics argue that prestigious science journals have refused to publish dissenting papers, forcing scientists challenging the Big Bang theory to resort to online platforms. Canadian physicist David Rowland contends that the red shift doesn't measure velocity, indicating galaxy expansion, but rather measures temperature and distance. Rowland highlights that the confusion between redshifts and the Doppler effect by early scientists led to the belief that the universe was expanding, a misinterpretation that persists today. Even Edwin Hubble, the renowned astronomer after whom NASA named its telescope, expressed reservations about interpreting redshifts as evidence of galaxies expanding. Hubble suggested alternative reasons for the redshift, refusing to accept it as definitive proof of galaxies' expansion. Even if there were a historical expansion of galaxies, it doesn't necessarily imply that the galaxies we observe today are still in the process of expanding. Our telescopes grant us a glimpse into the past, not the present. Interestingly, the Bible makes references to the heavens expanding at one point, portraying a concept similar to cosmic expansion. If the Big Bang did occur, there should have been a consistent distribution of gases throughout space. Such uniformity would hinder gravitational attraction, making it challenging for gases to gather and form planets and stars. Big Bang proponents introduce dark matter to explain the gravitational force necessary for star and galaxy formation. However, the scientific support for dark matter's existence remains elusive. Some scientists propose alternatives, such as modified Newtonian dynamics, MOND, challenging the need for dark matter. Dr. Dwayne T. Gish, a creationist scientist, argued that even if cold dark matter existed, it couldn't explain the massive galactic structures observed. Furthermore, an explosion fails to elucidate the precise orbits of billions of stars across billions of galaxies. While chance and random processes may explain disorder in the universe, the order observed suggests an intelligent design. Evolutionary astronomers suggest trillions of stars colliding, leaving surviving stars in orderly orbits. However, this notion lacks rationality, as the expected residue of gas clouds doesn't align with observations. A more logical perspective posits that stars die and decay into gas clouds and dust, challenging the evolutionary idea that these materials evolve into stars. In an attempt to interpret Webb observations, scientists proposed a hybrid model blending aspects of the tired light model and a cosmological model with evolving coupling constants. This model extends the time for galaxy formation, allowing for the development of well-evolved early galaxies. Nevertheless, further research and scrutiny are imperative to assess whether this model satisfactorily explains all cosmological observations. However, the plea for a new cosmology is not uncommon in scientific circles. Historical instances include Albert Einstein's dual explanation of light's characteristics and estimating the universe's age based on stars in globular clusters. The disparities between observations and the standard cosmological model prompt a fresh proposal advocating for an extended universe age. While this new model shows promise, further investigation is crucial to establish its validity and its ability to comprehensively explain cosmological observations. Notably, the James Webb Telescope's eagle eye recently discovered two of the most distant galaxies ever seen, aligning with the Big Bang Theory's galaxy formation framework. Facilitated by the gravitational lens of Pandora's cluster, these Galaxies, captured by the Webb's instruments, exhibit unique structures, challenging previous observations of galaxies at similar redshifts. The disparity in size among these early galaxies raises questions about their formation and subsequent evolution, creating intriguing diversity. Although their distinct properties challenge expectations of uniformity, both newfound realms strongly align with the Big Bang model. This model suggests that post-universe creation, galaxies initiated as small entities rapidly expanding through mergers and interactions with gas clouds. This expansion fueled increased star formation, enhancing the galaxy's variety and element abundance, incorporating heavier elements than hydrogen and helium. Uncovers galaxies, albeit young and small with a low, heavy element abundance, actively form stars, reinforcing the Big Bang paradigm. The James Webb Telescope's potential to detect even younger, higher redshift galaxies hints at more revelations about the universe's early stages. However, the absence of such galaxies in the Pandora cluster suggests either a specific time frame for galaxy formation or the need for more observational opportunities. Astronomers remain vigilant, employing various lensing clusters to unveil new perspectives into the profound cosmos, seeking insights into the earliest galaxies.